So in 1926, Charles Sherrington proposed a classifications of sensation that is widely used today. So he divided that into three broad classes, one being exteroceptors, two being proprioceptors, and three the interoceptors, which is basically vision, hearing, smell, taste, and touch. So with this, again, them being different, low power mode. So some of the specialized receptors are stuff that includes somatosensory end organs that are located in the skin, the limbs, and the joints, blood vessels, and muscles. The receptor type is identified by its maximum sensitivity to specific sensory stimuli such as heat, pain, touch, and its connection to the fibers that transmit these sensations. So the primary consideration for the function of any receptor is its adaptiveness to stimuli. Quickly adapting receptors respond strongly with the stimuli that's first applied. A good example is the mediate sensations of vibration, fine discrimination, and deep touch. Receptors are distributed in the tissue, skin, fingertips, palms, and lips. Another specialized receptor is conversely non-adapting receptors do not respond too vigorously to the stimulus onset. Once it's activated, they continuously provide signals to the brain as long as the stimulus remains present. So an example of that is mediate sensations of pain, temperature receptors that are distributed through the body, the skin. So that could be like if you're taking a hot bath and your water's too hot, you burn yourself, or you go get waxed and the wax is too hot, your skin's probably gonna get burned. So here in my diagram, we're gonna start. This is my right hand side. So this is the Merkel's discs. This is which they're unscapulated and they respond to light touch. Sorry, let me center this. So they respond to light touch. They're slow adapting and they're unscapulated nerve endings which respond to light touch, also known as discriminative touch. It's a light pressure that allows the location stimulus to be pinpointed. And then we go down here to the Pacinian corpuscle. And this is like an onion-shaped structure of non-neural connective tissue that's built up around the nerve ending that reduces in the mechanical sensitivity of the nerve terminal itself. So then we're going to move down to the Meissner corpusculus. Trying my best. This consists of a continuous nerve ending responsible for transmitting the sensations of fine, discriminative touch vibration. This is the most sensitive to low frequency vibrations between 10 and 50 hertz and can respond to the skin indentations of less than 10 micrometers. So I feel like you would definitely see it and feel that. Moving on is, I touched on that. So we go down here, and this is the free nerve ending. This can detect temperature, mechanical stimuli, touch, pressure, stretch, or danger. Thus, different free nerve endings, and it works as thermoceptors and mechanoreceptors and nociceptors. In other words, they express polymodality. So I feel like, again, with this, it's pressure, touch. If you put too much pressure or something, or like prime example, I went jump roping, bam, bruise. That's a good example. Okay, so moving on, the subconscious tissue, which is right here in my diagram. This is a layer of skin beneath the dermis, and it sometimes is called the subconscious fat or the hypodermis layer. So this layer provides insulation for your body, keeping you warm, and it also provides a cushion that works like a shock absorber surrounding your vital organs. So I don't want to wiggle my arm, but that's kind of fat. Just tissue basically. So that was that. And then the dermis, which is right here on my diagram up here. This is a fibrous structure that is composed of collagen, elastic, and other extracellular components that include vasculature, nerve endings, hair follicles, and glands. So the role of the dermis is to support and protect the skin in the deep layers, and that assists the thermoregulation and aid the sensation. So again, like, I don't know, I take collagen now. I want my skin to be as useful as it can for as long as it can. So yeah, that was really cool actually to read on that, because I see it in my face. And then lastly, which you see up here, is a hair follicle. So this anchors into each of the hairs into the skin. So the hair bulb forms the base of the hair follicle. In the hair bulb, living cells divide and grow to build the hair shaft. Blood vessels nourish the cells in the hair bulb and deliver hormones to modify hair growth and structure at different times of life. So you can see it in my eyebrows. It's growing. I have a bald spot here and there. Or even like in hair, you can see all these little baby hairs, stress, but it's coming through. So this is my diagram, and I hope you enjoy it. Thank you.